MIT just dropped a study showing 95% of GenAI projects fail, and we don't want yours to be one of them. That's why we released 2 masterclass videos: what is an LLM and how to choose a large language model. If you haven't watched them yet, go check them out on our channel. Now that you know what LLMs are and how to pick the right one, it's time to unlock the next level of AI mastery by understanding the difference between fine-tuning and RAG. 2 powerful ways to supercharge your LLM. Let's dive in. Large language models are an obvious topic in any AI interview prep. If you're still using old FAANG prep guides, you're already losing ground. The rules have changed, and this free AI playbook shows you what's really being tested in modern FAANG interviews. Insider strategies, hidden evaluation matrix, a 90-day mastery plan, the exact playbook successful candidates are using right now. Everyone's grabbing it. Don't be the one left behind. Link in description.
What does fine-tuning really mean? And then how does that compare and contrast with retrieval-augmented generation? So when it comes to taking a model and then injecting it with domain-specific knowledge, these are really the 2 broad approaches you have. So you can either fine-tune a model, which means you have specialized data that you use to train your model, versus in retrieval-augmented generation, you're basically having the model do a lookup, or actually you're having some code that sits in front of your model do a lookup to some sort of external source, and then it's able to retrieve some information, which it can then use to inject and add more context into the model, so the response is more grounded. So we'll take a look at what the 2 approaches are. So when you look at fine-tuning, fine-tuning is really a way to adapt an existing LLM without retraining it from scratch. So really, when you look at the purpose of fine-tuning, it's really to add domain-specific knowledge or domain-specific data into the model. For example, a lot of industries, they have sometimes very specialized terminology. They have a domain-specific knowledge, or sometimes there's jargon. This could even be company jargon, maybe not even industry jargon, which the model may not know what the context or what some of those words mean. A regular sounding word might mean something different in a specific industry. So fine-tuning is really a way to train these models using that domain-specific data. You can also use fine-tuning to adapt the style or even the personality in terms of how the model in terms of culture, or how it actually behaves in terms of its language and its style, so it matches with your organization. And then you could really optimize it for some very specialized tasks. We will take a look at a demo shortly, where we actually look at how we can fine-tune an off-the-shelf base model and make it more customized to a specific industry. So you can really think of fine-tuning is taking a model and turning it from a generalist, because these large language models are trained on such a large amount of data. They can really talk about any different set of topics. So how are you taking it from being a generalist into a specialist? So we talked about fine-tuning, really embedding knowledge directly into the modeling. But when you look at RAG, it's basically, it's a mechanism where the LLM basically gets external documents during the inference time. So when a question is asked, or when a request comes into the model, there's usually a piece of code or an application sitting in front of it. And, this is where this code is actually performing that RAG or that lookup, where it's getting knowledge maybe from an external database. It could be doing a search on the internet. It could be querying an internal system where it does this lookup, and then it uses that response, and it basically augments the context by augmenting the query and sending it to the LLM, so it can actually give a more grounded response. And in reality, it's not an either or decision. So when it comes to fine-tuning versus RAG, you can actually go with a hybrid approach where you could actually do both. So combining both gives you, better accuracy. You're going to have fresh and accurate data, and gives you better resilience as well. So there are some myths when it comes to fine-tuning. So, people talk about fine-tuning doesn't add new knowledge. It actually does. Fine-tuning does add new knowledge, because what it really does is it goes through the different parameters, and then it basically, looks at the neural network, and then it only modifies certain parameters within the neural network, and it does add new knowledge as part of doing that. You also hear RAG is always better. It's not necessarily true. It really depends on the use case. And we'll actually look at some techniques, because you'll also hear fine tuning is too expensive. That used to be the case. So in the past, fine tuning was a process where it involved, again, lots of compute and lots of data, and then lots of MLs, specialized ML practitioners. But now there's different techniques in which we look at what LoRA and quantized LoRA are, which really make it efficient and cheap when it comes to fine-tuning the models. So what is LoRA and QLoRA? So LoRA is a technique where you could fine-tune a large language model by adding small trainable adapters. So typically, if you were to do a full fine-tuning of the model, that's a very expensive process. Again, it takes a lot of data, lots of compute. But when you use the LoRA method, what it does is it doesn't go through every parameter. So if your model has billions of parameters, it actually just goes through a few of the layers of your neural network, and then it only trains a few of the adaptive layers in your neural network. So it's more efficient, and there's only a few parameters being updated. When you look at a quantized LoRA, it's basically LoRA where you reduce the precision, where you might lose some amount of precision because you're going down from 16 bits into 4 bits. So you lose some precision, but then you have the ability to run your fine-tuning on commodity hardware. So you don't need, very large, the small start GPU hardware. And in the demo, we'll actually look at, I'm going to run the fine-tuning on my local laptop using a Llama model. So you'll see it's actually a very efficient way to be able to fine-tune a model. With that, let's switch now, and we're going to do a live demo of what fine-tuning looks like. Okay, so I'm actually here in my browser, and I have a Jupyter notebook that I have open, and we're going to walk through. There's a bunch of cells we're going to execute, and the first cell we're going to walk through is installing some of the dependencies. So in here, we're going to be installing Torch. We're going to be installing Transformers. So Transformers is an open source library developed by Hugging Face. So you can think of Hugging Face as the GitHub for machine learning. And then we're also going to use the Transformers reinforcement learning library, and then the Hugging Face hub. Now, in my case, I have these installed, so you'll see the notice goes, the cell executes quickly. Next, what we're going to do is we're going to log into Hugging Face. So this is something, if you don't have an account with Hugging Face, you can actually create a free account, and you can create an API key, and which is what I'll be using right now. So in the next step, we're going to log into Hugging Face because I'll be using one of the Hugging Face models. And Hugging Face is a fantastic resource where they have literally hundreds of open source models available that you can use. You can even download and use these locally. If you want to use inference through one of the providers, you can do that as well. But it's a great resource if you want to do any type of development and work with the open source community when it comes to machine learning and a lot of the large language models. So I'm going to log into Hugging Face here, and I'm going to paste in my API key, and this is something which you can do just using the free account. Okay. So I am logged in to Hugging Face. Next, what we're going to do is we're going to import the Torch library. And in my case, I'm actually using a MacBook. But this block of code will basically, so if you have an NVIDIA GPU, it will actually use the CUDA driver, which will just make it more efficient for you to run through this training and even through the inference. So in my case, I actually have a Mac, so which is why you'll see it says using MPS. So if you're using Apple Silicon, so this is starting with the Apple M series. Apple moved away from the Intel chip set, and they actually use an ARM chip or Apple Silicon, which actually uses MPS, which enables the GPU processing on the Mac. So here, what we're going to do, and I'll walk you through this block of code. I'm going to execute this code because it can probably take a few seconds to run. But this is basically using the transformers library. We're actually importing a couple of libraries. We're importing the tokenizer library, and then we're also importing the model for causal LLM. So this is for us to basically chat with the LLM. And what the tokenizer does is, if you recall earlier, I mentioned, large language models don't understand language, they understand numbers. And what the tokenizer does is it takes text, any text we provide, and then it converts them into these tokens that the model can use. And that's really where we're calling this tokenizer. And you'll actually see here, we're using the Llama 3.2 version, and I'm actually using the 1 billion instruct model. The thing with instruct models is all the instruct models are basically good for chatting. So if you have a chat use case where you can sort of ask a question, get an answer, that's where the instruct models are good at that, because in addition to the pre-training, they're also trained as an assistant model. So the reason I'm using a 1 billion parameter model is because I'm running this locally on my Mac. But yes, could you use a 70 billion Llama model? You could. You just need to make sure you have a GPU which has enough VRAM to support it. But for this demo, I just want to pick a smaller model, which is why I picked the Llama 3 1 billion instruct model. And here when we set the messages variable, what we're doing is we're basically giving it a role. In this case, we're acting as a user to interact with the model. And then I'm also giving it some content. So this use case is for a healthcare use case. And the question that I'm asking the model is, hey, I'm a 35-year-old patient. I have fever and rash. Can you just give me a summary? And if you actually notice down here that the cell has finished executing, and the answer we get from the model is, it actually says, I can't provide a summary. I don't have the information, about your condition. So give me some details, and then I'll try my best to help you out. So now this is the response we get using the standard off-the-shelf, Llama model from Hugging Face. So what we want to do is we want to actually take this model and we want to be able to almost make it, like a doctor's assistant, where if I, were to ask the same question, I would actually get a more relevant answer with some sort of diagnosis and some sort of response, which is going to be more meaningful than, hey, I'm not a doctor, I can't help you, or give me more details. So this is where fine-tuning comes in. And I actually have some data in a JSON file. So it's actually, have a JSON file, and I'm actually going to load that in. So in this cell, I'm actually loading that JSON file in, and I'm going to, I'm going to run this cell. You'll actually see what's in the file. So in this file, there's really JSON objects, with two fields. So there's a consultation field. So this is where I have some information about the patient. And then there's also a summary field, which talks about, what are some of the complaints that the patient has? What are some of their vitals? So, what's the blood pressure? What's their temperature, and, with different vitals, their heart rate. I think the HR is the heart rate. What is the heart rate, and what are some of the other medications that they might be on? So I have a file here. Maybe there's about 100 or so of these examples. So what you see here is maybe just a couple of examples to give you a taste of what's actually what this data looks like. Next, what we're going to do is we're going to use from the datasets library. We're actually going to, we're going to import this data, this JSON data, and load it into our training dataset variable. So that will run quickly. Now, if you had, like a million lines of data, this might have taken a few seconds. But in this case, my training data is just like 100 of these JSON, JSON items. So it loads pretty quickly. Now, what we're going to do is we're going to, from the transformer reinforcement learning library, we're going to set up the supervised fine-tuning configuration. So if you notice here, some of the hyperparameters, so we define the configuration, using the sft config function. And some of the hyperparameters here are the output directory. So this is my local directory where I want to output the model, where I want to write the fine-tune model. I'm actually running 3 epochs. So the epoch is really the number of passes, the fine-tuning would take as it goes through the data. Generally, if you have a higher number, you do get a better performing model. I just picked 3 for this example, but This is something you would adjust since it's a hyperparameter. And then I have a per device train batch size. I also have a learning rate. So you'll see this is actually, it's like point, it's point followed by 5 zeros and a 1. That's basically what the learning rate is. You would adjust this based on your hardware. So I have a low training rate, so just because if it's on commodity hardware, it'll just run much better with a low training rate. And then I also sell, with quantized LoRA, the default is 4 bits. So that's why I have the number of bits from floating point set to false. So it actually uses lesser precision, but it's easier on my training. So I'm going to execute the cell. That does run pretty quick. And the next cell here is I'm actually defining a formatting function. So this is basically I'm constructing a prompt. If you look at our training data, there's really 2 fields here in the JSON. There's a consultation and a summary field. And that's really what I'm, telling the fine tuning is, the data will be coming to the model in this format, where there'll be a consultation and then there'll be a summary. So I'm going to run that cell, which runs pretty quick. So this is really the cell now where we actually will run the training on the model. So this is where I'm going to call the supervised fine-tuning trainer function. I'm going to give it the model, which in this case is our llama model. I'm going to pass in our config. I'm going to give it our training data set. I'm going to use, I'm going to take that data, training data, and tokenize that data. And then I'm going to use our formatting function that we defined here earlier. So I'm going to go ahead and run this. This process does take some time. So you'll see, it's going to progress fairly slowly. And it looks like my system hung. It just took a little bit of time. So I did run out of memory because I did prepare for this demo earlier. So I'm getting some memory errors, but the training is progressing because my system is struggling. So what I'm actually going to do is I'm actually going to stop this so I can recover my memory. I did run this earlier, and maybe I should have restarted my kernel. I did run this training earlier, and what I'll do is I'll actually go to a different notebook, and I'm going to rerun my my query to the fine-tune model. So I actually ran it earlier, and I actually put it in this output directory, healthcare fine-tuned. And if I were to rerun the same query, because I didn't want to sit here and wait, this process would take about 15 or 20 minutes for us to go through the training. So from a demo perspective, it's easier for me to just come into another notebook and just rerun the query. So it's the same query I ran earlier. So if you go back to our query that we ran here, so the query really was, 35-year-old female with fever and rash summarized, and then we sort of got this generic output. So if I were to go back and run it against my fine-tuned model, so I'm really doing the same set of imports, and making sure I use my GPU where possible, and I'm basically running my query here. I set the temperature and some of the other hyperparameters here, and then I pass it the same prompt, and this time I query the model, I query the fine-tuned model, I pass it my prompt, and then I pass it my tokenizer. So if I were to rerun this query now, it'll take maybe 3-4 seconds for it to query the model. And remember, this is running on my local Mac, and I think I do have limited memory, which is why we ran out of memory earlier. We should see a response come back. Okay, and there it is. So you see that this is a fine-tuned model output. So this time I gave it 35-year-old female with rash summarized, and it actually said, hey, you have fever and rash. It actually gives you an assessment. It sort of gives you some medication. It gives you, the blood pressure, heart rate. It gives you a bunch of other data, which you would not get if we hadn't fine-tuned the model. I'll run one more prompt. Let me just comment this one out, and we'll just run this other prompt here. In this case, it's a 15-year-old male with a headache summarized. So if I were to just run that, you will see we'll get that fine-tuned response from the model. Okay, it does take a couple of seconds, and we should see the output right there. Yep. So you'll see in this case the fine-tuned model output. It says complaint is headache, the assessment is migraine, and then you see the medications, you see the vitals here. So that's really the demo. So in summary, you can actually see the base model output really doesn't give you the right sort of response. But once we ran the fine-tuning model, you actually see those specific responses, based on the use case. So it's very domain specific. So really, in summary, as we just saw, Fine-tuning really enables that specialist expertise that you can leverage from your model, and you can also control the behavior. So in the demo, we saw, we were providing patient summaries, and then we wanted like a response back from the model, and we didn't have to really tell it anything. We just gave it the patient complaint, and maybe name and age of the patient. I'm sorry, not name, age and sex of the patient, and then boom, it just came back with the responses. So you also noticed we used quantized LoRA, so you can see it is cheap and fast. And had I not run it a couple of times before, I did the demo, we have not seen the out of memory issues, because I think it had already loaded the previous run in memory, which is why we had that memory issue. But if I were to restart it clean, you can run it on commodity hardware. So really, you want to use the best of both worlds with fine tuning and RAG. You don't want to start small. You don't want to, machine learning and working, fine tuning models is an iterative process. So you have to sort of keep iterating on it and refine it and sort of keep coming back. So with that, it is a wrap. I really appreciate you taking the time to attend the session. If you're looking out for GenAI or other agentic AI related courses, you can check out the IK webinar for a lot more around these topics. Okay, with that, thanks again and have a great day.
If you like this video, you will love what I have to say next. The 14-week agentic AI program at Interview Kickstart helps engineers build real career-ready skills. You'll work on 2 live projects with FAANG instructors and leave with portfolio work that actually makes a difference in hiring. Over 20,000 tech professionals have already trained with Interview Kickstart, with many moving into roles paying upwards of $300K. Want to learn more? Join the free upcoming webinar, ask questions, meet the instructors, and see if it's a fit. Not ready yet? No problem. Start with the agentic AI building videos here on the YouTube channel. We recommend this one. Either way, the key is to just get started.